In this video, we will be talking about red teaming and how it applies to the cybersecurity world as well as AI. We will be discussing the following. How is red teaming defined in the cyber world? How is that definition limited when it comes to evaluating Gen AI? Are there any best practices or standardized processes from cyber red teaming that can apply to AI red teaming? Can responsible disclosure practices from cyber be applied to AI vulnerabilities? And what policies currently exist for AI red teaming? In the cyber world, red teaming is the practice of emulating threat actors and deliberately taking action against a range of targets. This includes activities such as finding and exploiting weaknesses of a mobile application, or targeting members of an organization through social engineering, or evaluating an entire enterprise's digital footprint or attack surface from the perspective of the red team. While there is some overlap, cybersecurity and artificial intelligence are very different domains, and the concept of red teaming does not port seamlessly from one to the other. Limitations to consider when translating a cyber approach to red teaming to AI include: are there many established threat actors for AI? Leading organizations often release reports on advanced persistent threats or other known or inferred threat actors out there that have preferred tactics, tools, and procedures, or TTPs, as well as targets. Are there common vulnerabilities or exploits for AI? There are resources publicly available like MITRE's Atlas framework that lay out the tactics plus techniques in addition to case studies. The risk surface of generative AI is much broader than cyber. The outputs of Gen AI systems are often more diverse and unpredictable. Assessing properties like bias and data poisoning is a lot more nuanced than addressing many cyber vulnerabilities and can involve challenging ethical considerations. Conversational tricks and subtle prompt modifications are much more dynamic than most vulnerabilities and exploits when it comes to the cyber world. As there are more interactions between an AI model and users, and the model learns from the users, the exploits also evolve over time. Drawing from lessons learned in the cyber domain, the following best practices can enhance AI red teaming and minimize chances of repeating past mistakes. Utilizing mixed talent. Crowdsource talent through bug bounty offerings, as well as consulting companies that specialize in red teaming. Expanding beyond just red teaming and generating recommendations and solutions based on the findings of the exercise, not just providing a report that lists the vulnerabilities found. Keeping the list of informed small, not letting certain stakeholders of the AI product prepare for the red team exercise for the purpose of preventing an honest red team attempt, which could result in a flawed outcome that does not emulate real-world risks. One key part of red teaming and offensive cybersecurity is responsible disclosure. When a vulnerability is found, how should that be handled appropriately? In cyber, we have third-party organizations like CERT and CISA that can help communicate between all involved parties, such as the person who found the vulnerability, the developer or organization that owns the product with the vulnerability, the community or general public that uses the product, and subsequently would be affected by threat actors exploiting this vulnerability. CERT, CISA, and other organizations have guidelines that usually start with giving 45 days before going public with the vulnerability to give the product owner time to remediate the vulnerability. Granted, there are multiple factors to consider. Is the vulnerability found in critical infrastructure? How widespread are the impacts of the vulnerability in the community? Is it tied to a unique use case, such as a small community that uses the product? Or is it widely used? Think CrowdStrike and Windows. How would exploiting this vulnerability affect people for first, second, and third level of effects? For example, a first level of effect from the recent CrowdStrike outage was Windows devices internationally crashing with the blue screen of death error. A second level of effect would be the outage and impact to businesses that rely on Windows devices with CrowdStrike products. And a third level of effect would be loss in reputation and shareholder value for CrowdStrike and other companies utilizing its products, such as major domestic airlines. What is the solution for the vulnerability, and how does that solution get delivered? How does all of this apply to the AI domain? Is a general time frame of 45 days sufficient to give to the owner of the model before releasing notice of the vulnerability publicly? For example, foundational models often have branched off child models that are fine-tuned from the base model. What if the vulnerability affects child models as well? Correcting data issues like bias can be a lot more resource-intensive than patching a vulnerability that allows for remote code execution. For example, there has been lots of recent interest in machine unlearning for minimizing the impact of problematic training data. However, machine unlearning has proven to be extremely difficult and has inconsistent results in practice. What is the use case of the vulnerable model? Is it used for self-driving cars or for everyday people's photos to be enhanced with AI? How patchable is the vulnerability? Some AI vulnerabilities are not patchable in the traditional sense. For vulnerabilities that cannot be patched, immediate public disclosure may be necessary to minimize impacts. How do first, second, and third level of effects look like with AI? For example, a first level of effect from a large language model being exploited could be harmful responses being provided that should otherwise be prevented by guardrails. Whereas a second level of effect would be the potential loss of LLM availability until the harmful response vulnerability is identified and remediated. And a third level of effect would be losses in both costs and reputation from this vulnerability for both the model owner and any downstream applications utilizing this model. So why the interest in red teaming with AI? First, the Executive Order on AI Safety and Security released in October 2023, which has a goal of leading and governing AI development in a safe and responsible manner, encourages red teaming generative models. Specifically, it calls for establishing guidelines to ensure safe, secure, and trustworthy AI systems are deployed, developing and fostering testing environments for AI, fostering collaboration, developing tools and plans to help assess models, develop mitigations, or help better imitate threats against AI systems in critical domains. Producing practices and seeing what leading AI experts are currently doing with red teaming and the outputs of red teaming. In response to the executive order, NIST recently released NIST AI 800-1, titled Managing Misuse Risk for Dual-Use Foundational Models, that details best practices for red teaming Gen AI. Some notable best practices excluding details already discussed earlier in this video include clearly scope end state and goals and accountability for the red teaming exercise. Compensate for any gaps and adjust where need be to ensure the red team can emulate a threat actor as realistically as possible. Consider legal protections for the red team as they test the AI system, and ensure appropriate diversity in the composition and expertise of the evaluation team. In conclusion, while there are major key differences to consider between red teaming in cyber and AI domains, we can learn and build off of the foundation of best practices established in the cyber domain to minimize the consequences that would result from misuse and exploitation of AI models and develop policy to encourage the safe and responsible use of AI. Traditional software systems and AI systems have significant impacts across most industries. Policy has successfully mandated safety mechanisms and established best practices for software in the cyber world, and it is imperative that the same is done for AI systems.